My name is Tyler Reid, and I'm the manufacturing specialist here at GoEngineer. Thank you for joining me today for this CAMWorks 101 webinar. I put this together really to show some of the turning features today. And the turning portion of the software is something that we've kind of neglected over the past few webinars. And so I decided to focus on turning today. And for those of you looking forward to seeing some milling features, we are going to cover some milling at the end. We can't escape it. But this is going to be like a 101 level view into the turning portion. So it's going to be a fairly basic overview of some of the features that CAMWorks has going for it when creating parts to be turned on a lathe. This is a basic intro, but there are going to be some tips and tricks in here for the experienced user. So don't shy away from that. Stay tuned here. It's going to be about 30 minutes I'm shooting for. We might bleed into 40 minutes. It really depends on how long this part takes me because I haven't done it before. So this is being broadcast live, webinar style, meaning you guys can hear me, but I can't hear you. So if you have any questions, feel free to type them into one of the two GoToMeeting boxes available to you. We have the questions box and the chat box. I'll kind of have my eye on both throughout the show, and there will be a dedicated Q&A session at the end. So the turn features I want to talk about today, I want to get the point across that automatic feature recognition like we know it in milling is part of turning. The turning workflow is very similar to milling. There are some minor differences in what we can do in the picks and clicks, but overall, the feel of the software is very similar. When programming on the lathe, we have support for twin turrets, so front and rear turrets. They're becoming very popular today to have a front turret. And I believe on this part, I'll probably try to show the twin turret functionality. We can also do twin spindles, so a main spindle and a sub spindle. And within there, CAMWorks gives us some sub-spindle templates so that we can program actions with the sub-spindle, such as grabbing the part, transferring the part, etc. And something called the Spindle Sync Manager, which actually should be tied into the twin turrets there because it's all about syncing the turrets. And then lastly here, after we program this part for the turn, we're going to run a simulation, save the work in progress as an STL, and we're going to use that as a milling setup, and we'll finish the part on the mill. In the past, we've done a mill turn webinar where we program the turning and the milling on the same machine. In this webinar, we're going to separate it out onto two separate machines and show you kind of what that workflow would look like. So let's hop into the software. I've got a part here that's fairly complex. This would be a good candidate for a mill turn part if you had that machine capability. But in this scenario, we don't. So we're going to program the lathe portion and then the milling portion separately. All right, so this part was created in SolidWorks, which is helpful because if I want to know the size of any feature, I can click on a face. It will highlight the feature that was used to create it inside SolidWorks, and I can kind of investigate that. So I might be doing some of that later on. So I'm going to hop into the CAMWorks. We got the CAMWorks feature tree, the black CW tab above the SolidWorks feature tree. I'm going to be programming this on a lathe, so I got to make sure I have a turn machine selected, and I do. I'm actually going to want to do the turn inch 4-axis because that has front and rear turrets. That's the way it's set up in the TechDB. And I'm going to experiment a little bit with that. Obviously, if I was programming on a mill, I would choose a mill machine, or a mill turn machine, I would be selecting that. It really kind of all comes down to what post you're going to post out, because the posts are tied to a certain type of machine. I have a tool crib portion just like I do in milling, post processor. One thing I do want to check is the chuck. So CAMWorks gives us the ability to visualize the chuck, and it's always going to come in with the default chuck. It's 4 inches. It's a little bit small for this part, so I'd come in here and edit that. I have some default chucks that have been built different sizes and different number of steps and teeth. I'm thinking something like an 8-inch chuck. Looks like a pretty good size. You can edit these built-in chucks and save them here if you have a chuck that is slightly different in dimensions. So I've got my chuck selected. Let's make sure I have a good post processor selected as well. All right. Next thing I'm going to take care of is the stock. The stock in turn mode, we have 4 different options. One is a minimum bounding cylinder, very similar to what we're used to seeing in milling. We can also create stock from a revolved sketch, a revolved work in progress file, and an STL file. The work in progress file is something that is saved from a simulation from another configuration. It's actually really similar to what we're going to step through today towards the end here. So I'm just going to use the minimum bounding box or cylinder here. I'm going to add some on the OD. I'm going to add a core just to make our life a little bit easier. So our stock is cored out. I'm going to add some overall length up from 5 inches to say 9 inches, maybe 8 inches. And then I'll offset that. If my length of stock is 8 inches and say I want 20 thousandths on the front face, my offset is going to be minus 7.8. And that will give me 20 thousandths on the face. Choose my material. Just go with the trusty 6061, and we're good to go on the stock. All right, so I'm going to run through the feature recognition here and give you guys an idea of what it finds in turning. Feature recognition, if you've been following these webinars, you understand that it's meant to give you a good head start. And in some parts, it gets you 50% of the way, 70% of the way. In other parts, it gets you 20% of the way. It's kind of just, based on the geometry here. On turning, it usually does a pretty good job, but there are a couple things that we do almost all the time in terms of finessing the results. So it gave me one setup, which means it's going to want to machine everything from one direction. And if we look at the coordinate system here, it's coming from, the tool would be approaching from screen right to left. Okay, and it found a face feature. And in turning, the features are going to be just green line segments. Okay, found a face feature, an OD feature. And notice it does a good job of taking the revolved section, meaning we got a nice little tab here. My turn features are going to cut around that tab. ID feature. We got a rectangular groove over on this side and a cutoff feature. So this is a good start. This is pretty much par for the course for turn because in this particular case, I've got a sub spindle. I'm going to transfer this part halfway through and I'm going to cut it from the other side. So I'm going to do some things up with the features that it gave me to make that happen. First thing I'm going to need is a second setup in the opposite direction. That's pretty simple. Now that I've got that set up, I'm going to try to piggyback off the features it gave me, meaning I'm going to copy features from one setup to the next. I'm going to do that by holding the control key, clicking on the feature and dragging it. So something like the OD feature and the ID feature, I'm going to copy those to both setups because I'm going to cut the same geometry just from different directions. It's a nice little shortcut. Something like this groove, it's on the far side of the part. I'm probably going to want to cut it from the left side, so I'm just going to drag it over. I'm not copying it. I'm just moving the setup. The cutoff feature we're going to nix. We'll just delete that because we're not going to do a cutoff. And that about does it for what I can use that it gave me. Now I'm kind of left to creating some of my own features. So I'm going to kind of think about what's missing here and how might I cut some things differently. So the face is good. The OD, I really don't like how it's dipping down into this groove. And I actually probably want to come in with a groove tool and cut this geometry here. So I have two choices. I can go into this OD feature and I can edit it and make it just skip this portion. It's kind of the long way. What I'll do is I'll just create a new feature. And it's going to be a groove generic type. Generic is in reference to the shape of the groove. The other two options are rectangular and half ob-round. So groove generic, a course strategy. And then it may be difficult to see because of the color of the part, but we have some line segments here that if I hover my cursor over, they turn magenta. These are how we select features in Turn. So instead of selecting faces, we're really selecting segments that represent the revolved shape or the shape of the part at a particular plane, which in this case is what we're looking at because of this area over on the left here. The part profile method is plane section. And I'm not going to worry about changing that because in this particular case, I have what I need to select here, which is these two segments. So I'm going to run my groove tool along those two. And we'll call that good. And then on the second setup from the other direction, I'm going to do the same thing on the other side of the flange. So a new turn feature, groove generic. Oh, and actually on this side, I don't have the line segments that I need to select because of the plane that it's using. So in this side, I actually will change this plane section to revolve section, and my line segments to choose from will update. All right, so now I do have a line segment that represents the revolve section there. And we're good to go there. Okay, I'll probably want to face off this side so I can add another feature. This time a face feature. And I will just choose that line segment on the end. Zoom in so you guys can see that. Leave it at a course strategy. I can add extends here, or I can do it in the tool later on using a start and end. So something like an extend along Z or X, reverse it so it's coming off in the right direction. And that allows you to extend the feature beyond the line segment that we have. All right. Now, within the features that it gave me, we can see the names there. Face feature 1, OD feature 1, etc. And then in brackets, we have the words course, course, drill, course. That is the strategy. Same way we have strategies in milling, like rough finish, coarse, fine. We have strategies in turning. And those strategies are going to dictate how you cut that feature. The default strategy for ID features out of the box is drilling. And we're not going to cut this feature with a drill. So I'm actually going to want to come in here and change that strategy to something like coarse. And that's going to bring in a boring tool. To change the default from drilling to coarse is not a big deal. That can be done in the TechDB. And I'm more than happy to help somebody do that if they are interested in doing that. All right, so those are both coarse now. I'm feeling pretty good about this so far. So I'm going to go ahead and generate my operation plan. Generating an operation plan works the same way as it does in milling. It takes all of these features that we have. It takes the type of feature. So is it a face, OD, ID, groove? Takes the shape of the feature in the case of grooves. Takes the strategy we've selected. It takes whether or not this is a main spindle or sub spindle operation. A bunch of different parameters, and also the material group. And then It runs each of those features through the database until it finds a matching entry for all of those parameters. And when it finds that entry, the database tells it, create these operations, face rough, face finish, using these tools or inserts and holders in the case of turning. So the next step here is, we've actually got all of the data within these operations at this point. We've got the tool. The tool includes the insert and the holder, the direction of the holder, how it's approaching the part. We have all the parameters of the toolpath. So the depth profile, the allowances in X and Z. Is this going to be a can cycle? Is comp on or off? Am I approaching this in X or Z? Lead-ins and lead-outs. All of the nitty-gritty details are here. So the next step is actually generate a toolpath. And all that does is tells CAMWorks, use the data in these operations, apply it to the part. Okay? And so when I do that, we get a nice little representation here. If you've been using the software on the milling portion, you recognize a lot of this. The red dotted line is a rapid move. This blue line is a feed move. Some of the lines that you probably don't recognize is like this orange line here. That orange line that looks like a cylinder right now represents the work in progress. So in turning, CAMWorks will actually keep track of what has been cut and will automatically run tools only where there is material to be cut. And this is a very important distinction between turning and milling, because it can cause toolpaths to not be created when you think they should be. Like maybe in this case of this groove, or these groove finish operations over here that remain pink, so we know that there's no toolpath there. It can be very frustrating to remember that if you're out of the habit. So it is looking at the work in progress the entire time, and it's giving us a real-time update as to what the shape of the stock will look like after the operation finishes that we have selected. Okay, so in the case of this turn rough, if I zoom in here, we've got the orange line running just above the part in X and Z. And actually, because of the angle of the tool, we get this nice little geometry here. All right, so it's keeping track. And what's happening is, because of the way it's programmed right now, this turn finish operation is finishing it to size, because the tool is actually able to dip down in here. And so when it comes to that groove that I created, there's no toolpath because there's nothing to cut. All right, so we got to deal with this, because I don't want to cut it with that turn finish. I want to cut it with the groove. I also don't want my tools to run the entire length of the part. So we're going to come in and edit some of these toolpaths. Let's start out with the facing is actually good. So we're going to leave the facing. Let's start out with the turn rough. Come in here. I'm not going to mess with the tooling. I will kind of go over this. We've got a couple sub tabs within the tool tab. We got station, where you can control the station number. If your machine is set up to do substations, you can input that number here. We also have this gauge offset XYZ. This is to help you actually use gang tooling within turning, which is probably above the 101 level webinar we're trying to stick to here. But CAMWorks does support gang tooling now in turning. We have control over the insert and the holder, like I mentioned. One thing that we do mess around with, and something to keep in mind, is the orientation of the holder, which is controlled down here. Sometimes what will happen is, out of the TechDB, we'll get an operation that doesn't generate a toolpath. And one of the first things we should look at when we're in turning is the orientation of the holder that we have saved in the TechDB. Because if we choose an orientation that is incompatible, like this, we'll get no toolpath. So we're going to stick with this here. We also have a tool crib. And actually, I'm going to make a change here. So within the tool crib, here is one spot that we can change what turret we're using to cut a feature. So we actually have two tool cribs in turning. We have one for the rear turret and one for the front turret. And if I change to the front turret here and choose a tool on the front turret, hit preview, I'm going to have to change my orientation. Now my toolpath is on the front side of the part, and I'm using the front turret. And we're going to keep it like that way, actually. So some other things in here, we've got depths of cut, first, max, final, just like we do in milling. We have some allowances. So in milling, we have side allowances and bottom allowances. In turning, we have X and Z. And we have these boxes here that give allowances over the entire part. But we can also do variable allowances. So if we check that box and go into settings, we can actually set X and Z allowances for individual line segments. So if we know our machine is out of true at along a certain portion of the slides, or we're getting some parts off the machine and they're just out of tolerance on a certain portion, we can come in here and adjust those in the program instead of doing it at the machine, or changing the program to match what we're doing at the machine. All right, so I'm going to leave this here. Oh, actually, no, we got to keep this from going all the way down the part. So to do that, we're going to use something called a Z limit. So Z is in this direction down the length of the tool, and we're going to limit the tool in Z by saying user defined, use this pick a point button, and I'm going to stop it. I'm going to pick a edge. We'll say this edge here. I'm going to stop it there. Hit preview. Now my toolpath is pulled back to the back side of the flange. I'm going to go ahead and leave that. Now I have to do the same thing for the turn finish. And I'm going to put it in the exact same spot. If I don't do this for the turn finish, we're going to crash the tool. Because the turn is going to want to go all the way down the part, and all of a sudden it's not cut beforehand. So that's going to be a problem. All right. And I'm also going to put this OD feature on the front turret, the finish as well. So now my toolpath is on the backside. And in the feature tree, or the operation tree, in brackets, for these two entries, we have front, and the others we have rear. All right, one thing I want to do now is generate the toolpath for everything, because I've changed the toolpaths in the turn rough and the turn finish, and my work in progress has still updated. But until I generate the toolpath up here for everything, these groove tools will not know that the previous toolpaths have finished. I hope that makes sense. These grooves are relying on the toolpaths of the previous operations, and if we regenerate an individual operation, that doesn't automatically get propagated to operations down the line. Real quick before that, I'm going to use a setting here to prevent the tool from dipping down in here because I'm still cutting it. Within the turn rough, you can uncheck this undercut option, and that's going to keep the tool from dipping down and cutting using the back side of the insert here. And I'm going to do that for the turn finish. No undercut. And so we can see now after that turn finish, my work in progress is still, it's actually undercut now, but my grooves have not generated. But as soon as I hit generate up at the top, now we're going to do the same with the bore. So I'm going to go to a step on the inside on the ID. So my ID toolpath, my boring bar is only going to go down a little bit past halfway. And I'm going to do the same thing on the boring finish. Use that same edge. Okay, we should be sitting pretty now. So my groove tool is coming in and finishing it to size just like we want it to. Coming from the other side, all my tool paths are generating. And let's take a look at these. So the turn rough from the other side automatically, without me telling it to, stops at the flange because it is working from the work in progress here. So because I copied the feature, I use the same feature in both setups. I only really have to program one side, and I let the work in progress functionality take care of the rest. The boring does the same thing. We got the bore finish. We got a groove in there. That was an automatic feature recognition. And we got our facing. So we're looking pretty good. We have a couple extra finishing groove tools in here. And that's because in the TechDB, the core strategy, it actually includes 2 groove tools, 2 groove finishes. That's a good example of something I'd probably want to save back to the TechDB is get rid of this second groove, just delete it. Come to the feature that I use to create those tooling and say save operation plan and overwrite the existing feature condition. That way, I'm kind of teaching CAMWorks how I cut a groove of this size. I'm only going to do it with one tool. And so I've just taught it, and I've made it more efficient, which is one of the best things about CAMWorks. So there's a couple other things that we got to do before we're done with this. One is we got to handle the handoff, the transfer from the main spindle to the sub spindle. And we also want to make sure that our front and rear turrets are synced up how they should be. So let's do the transfer first. Within the first setup, right click, and we're going to go to new sub spindle operation. And we have a selection of templates here that we can use. Each of these templates is built specific to your post processor. And they really just allow you to have a user interface to control the finite steps that have to happen during, say, a transfer. So if I select standard transfer, it's showing me all of the steps. The main spindle is going to turn off, then the sub spindle, then they're going to orient. And each of these steps, we read them in words, but they're going to be translated to the direct M codes and G codes needed for your particular machine. Then the sub spindle rapids over, feeds in over the other part, clamps onto the part, waits 5 seconds. The main spindle unclamps, and then the sub spindle moves home. Okay, within each of these, if we click on it, we can control what's actually happening. So if we wanted to change that dwell from 5 seconds to 2 seconds, we can do that. We don't got time to waste 6 seconds. All right, and that's the transfer, and we put that at the bottom of the operation tree because that's the order it's going to post out. All right, and then let's take a quick look at the sync manager. The sync manager is showing me the tools that I'm using on the rear turret and the operations I'm cutting on the front turret. I actually can grab these and drag them over to the other side and change turrets. I can also grab them and rearrange them the order within this menu. So this menu is also another way that you could move an operation from front and rear turret. This menu is all about posting the right weight codes in your G code. So the G code is going to get posted out in two separate G codes, and you load it onto your machine, two separate files, one for the rear turret, one for the front turret. You start them at the same time, and then they're given wait codes so that they're properly synced up and cut when you want them to in relation to each other. It's a nice interface to keep track of that. So real quick, let's run into a simulation here. I know I'm going to save out the results of this simulation. So I'm going to come into the options. I'm going to bump the quality all the way up and let this run. We got the transfer. We're cutting from the other side. Looking pretty good. I'll run a comparison. I'm undercut in places where I'm going to need to use the milling tools to cut the features. So I'm actually looking pretty good. You know, outside of a couple tight corners that I can't reach down into, which is par for the course on the turning, I've programmed this completely. So within this menu, I can save the work in progress as an STL, because what I'm going to be doing here is I've programmed it on the lathe. I'm going to send the G code out. I'm going to cut it. And then I'm going to take this piece and do a secondary op on my milling machine. And I want to start out with a nice piece of stock within CAMWorks when I program that, because that's going to actually help me not really program it, but simulate it accurately. So I'm going to save this STL. I'll just save it on the desktop here. STL, inches, we're all good. Okay. So at this point, I'm going to save this. And within CAMWorks, I'm going to open up the configurations tree, and I'm going to add a new configuration. So like in SolidWorks, where configurations are used popularly to have different versions of the same file, maybe it has slightly different geometry. We can also have CAMWorks configurations. So using the same part file or assembly, we can have different versions of the CAM programming. So this is very common if we have separate machines for turning and milling. So now in the second configuration, it's set up for milling. I've got a mill machine selected. All right. Within the stock, I'm going to choose the option to read in an STL file, and I'm going to browse to that STL file I just saved and look at the representation or the silhouette of the stock now. All right. So before, it looked like a cube. And with the STL, it looks exactly like how we were going to cut the part coming off the lathe. And that's what I'm going to keep it as. So I'll change the material here. And just real quickly, I'm going to program some of these mill features. I'm going to do it all manually. So let's create a mill part setup. Say we're going to cut in this direction here. These are all 2.5 axis features. So we got some slots along the top. I've got the multiple box checked here, so I can pick several faces and create several features all at the same time. Up to that face, rough finish, we're good there. And we have some holes, so we'll do the same thing with the holes. We'll grab these top edges. I grab the tops of all of them, and now on the next side, I'm going to click this bottom face because they're all the same depth, so I can get away with creating them all at the same time. And we'll just keep a drill strategy. In this hypothetical part, we don't have the need to bore it or ream it, so we're going to just drill it, but we are going to click this through box because these are through holes. And the last piece of geometry here is this outer ring on the flange. And I don't think I'm going to create it with this wizard because there's no good way to select what I want to. I really want to select, I want the feature to start at this face and come all the way around. So I would need an edge of some sort. I don't have it. But because this happens to be around the outside of the part, I can create this as a part perimeter feature, a boss type, which is just going to create a contour mill around that. And we are good. Probably one of the difficult things about cutting this part is going to be these faces here. And especially since this is turned to this OD right now. And so if I just use a standard drill, it's going to wander right off. Right? We're not going to be able to cut that with a drill. So I could do two things. If I could bring in an end mill and just swoop it in, kind of C-shaped, or I could just circle the whole part. That would be very easy to program. Or I could bring an end mill in straight in and just kiss it. Luckily, this is kind of hypothetical, and I don't know which would work out the best, so maybe I'll just program the kiss. I like that. So I don't know what size this is. This hole, if I click on this edge, it tells me in the bottom here it's 400 thousandths. I don't have a tool that's 400 thousandths. That's not a standard size. So whoever designed this, if I click on this face, it looks like they just used this cut extrude. They just sketched a hole. They didn't even dimension it. That's terrible modeling practice. Don't do that. Create holes that are standard size holes. Makes programming it easier, the machinist's job easier. To kiss it, I'm going to have to follow a line. So I'm going to start a sketch on this face, and I'm going to use this existing edge here. Just something like this. I'm going to run my tool right along the center of that using something called a curve feature. So this is a 2.5 axis feature. A curve feature allows you to select a sketch line or an edge on the model and run your tool centered on the sketch line. It doesn't offset it like the open profile feature does. So my feature is this tall, and that's not the exact length or depth that I actually want to cut, but it's convenient. And so I'm going to create my feature that way and then maybe use some Z limits to limit that later on. All right, we're good. So I'm going to generate an operation plan, run these through the TechDB, generate some toolpaths so I have something to look at. All of these slots I'm going to cut the same. So I actually could do two different things. I'm going to show you both ways real quick. I can control select these rough mills, right click and say combine. That combines them into one. All right. I could have also linked them instead of combining them, which would have also been a right click. But something that's kind of cool, and somebody on our YouTube page was talking about earlier, I'm going to delete all of these rough and contour mills, get rid of them. On the feature side, here's my features. I'm going to group them. So if I click all of these, well, if I click one, right click, and say create group, and then add all of these to that group, that cleans up my feature tree. They're grouped just like the holes. And when I generate my operation plan, it will create only two tools that apply to all of them. So it's kind of like combining, but it also cleans up your feature tree, which is nice. The center drill and the drills, we're pretty good there. Something to look at is the rapid movements between them in this sort of situation. Also, the length of the tools. We got to make sure the holder isn't going to collide, which we won't worry about in this webinar here. Here's that part perimeter to get the flange. Here's a perfect example of where I might use Z limits. So under the advanced tab, an upper Z limit will say user defined, pick a point on top of that flange. Lower Z limit will pick a point on the bottom, and it'll actually maybe offset it a little bit in the Z. So it will go slightly down below that. And now we've got just one tool around the outside. That tool is probably a little big for this radius. So we could choose a smaller tool, say a 1/8 inch tool. All right, I'm not going for perfection here. And then the last thing here, again, Z limits to kiss this face. We'll add some Z limits under the advanced tab, the top. Again, I'll pick a point and I'll pick that point there. And the Z, I'll pick the bottom and again, offset it just a tiny bit. And I'll also adjust my depth of cut because I'm basically using the whole flute. So on my tool, oh, I picked a tapered tool, so we don't want that. We really want a tool that fits this radius, right? And I measured at 400 thousandths. So what I'm going to do is I'm going to come to my tool selection filter, say flat end mill. I'm going to limit the radius here from 400 to say 4.5. So it's only going to show me tools within that diameter range. 406, 1330 seconds is probably as close as it's going to get. So I'll use that tool. Looks about the right size. Make it a little longer just because we have that ability. All right, and then my depth of cut, I'll use a little bit deeper depth of cut than I would normally do because this is not really a standard cut. So something like that. It's just going to come in and kiss the wall. And we'll come back to our feature that we used to create that, and we're going to pattern it. I just have to create click a circular edge. And it's going to take its best guess as to how many instances I want, and it guessed correctly. And we're good. So now that one operation is going to cut all of those. So when we go to simulate it, the starting stock is going to be very accurate. And this is going to help us know if we are programming correctly because we didn't have to do that step of saving out the STL and reading it in as the stock. But because we did, it's going to make this visualization a lot easier because if we started out with a block of material, it would have been very difficult to keep track of what was being cut and if we're colliding with any features or anything like that. So we'll let this run through. I probably should have done a little bit different method to cut that flange. Instead of doing a boss type perimeter, I should have done an open pocket, and that would have started at the flange and cut outward until we were out of stock. That way I wouldn't have created this ring. But overall, we're good to go. We programmed this part, and we did it in about, 48 minutes. So I took a little bit longer than I had hoped, but we did it in full, and hopefully that gave you guys a pretty accurate workflow and experience using the CAM. With that, that's pretty much all I had for you guys. Thank you for joining this 101 seminar. We'll be doing another webinar next month. It'll probably be a 201 series, which means it'll probably be a little bit more in-depth. I don't plan these out very far ahead of time, if this was any evidence to you. So if you have any suggestions as to what you would like to see, feel free to shoot them my way. Here's my contact info, treid@goengineer.com. More than happy to take a look at any parts you guys have, answer some more in-depth questions. But, thank you for joining, and I'll see you guys next time.